Right. I would say we start with your questions first, and then we can, when they are running out of questions, we can go over maybe some question in the midterm. But let's leave that as a last. Okay, since I'm going to post a solution anyway. However, I do have a question for you to start with. How about we start with that as exercise together? I want you to look at this class over here with the post condition. Okay, let me go over that with you very quickly. Okay, it's to clarify the concept. Let's do it together. So now I have a class called points, two-dimensional points, where I got x and y. Let's say for simplicity, just integer, two attributes. Okay, and then I'm trying to say redefine the is equal feature, which we did in lab number 1. This is the is equal feature over here. Okay, and then it's going to return a Boolean. So now everything is set up properly, and what I want to ask you about is look at the post condition over here. The post condition looks like this. Ensure x equals other.x and y equals other.y. That's the post condition. For the implementation, let's not worry about it. So the question is the post condition in pink appropriate or not? That's the question. Okay, think about it. This is kind of the question we would expect you to answer, right, to test your understanding. So do think about it. Now you have time. Nothing to do with copy. How about this? Oh, okay, I see what you mean. Basically, what you're saying is, okay, to really make sure, okay, you can think about this is about, let's say, post condition 1. I'll put post condition 1 tag over here, right? What you're talking about is post condition number 2. Let me put it down so there's no confusion. I can say the current points after the feature call is the same as, actually this would be, yeah, would be equal to, basically that's what you're trying to say. Let's say we got something like that already, so that's not an issue. Okay, I want you to focus on the pink post condition. Is it appropriate or not?
What did you write before inside
P1 and P2. Which one?
Inside the is equal method.
Oh, this one here. I'll try to clarify that, but this is, don't worry, this is not going to really appear in the test. So just briefly speaking. So this is a keyword in IFO. Basically, we're saying that the type for other is going to be just the same as the current objects, which is points. Like, L-I-K-E, like current. I think all of you were required to actually change that, right? I'll talk a little bit more about this, something to do with inheritance after midterm. So don't worry about this one, okay? Nothing wrong with this. Okay, now, how many of you would think this post condition is fine, P1? So you don't think it is okay, right? Can anybody explain to me why you think it is not okay? Huh? That's not an issue. So we're talking about P1 only, P1 itself. Logically speaking, what's the problem with P1? Yes, go ahead. Nothing about short circuit. Okay, you know, it's a very good concern over here. Basically, you only worry about a short circuit if the left-hand side has a possibility of failing or crashing. Over here, you can see x equals other.x. You might thinking about like a null pointer exception in Java. Other could be null. But however, in IFO, actually, we're going to address this after the midterm. It's something called void safety. So yeah, so I would say that's not an issue either. Okay, nothing about comparing copies of the objects. Nothing about short circuit. I'll give you a little bit hints, okay? I'll give you a little bit more hints. Think about the following scenario. Let's say we have conceptually P1 and P2. Let's say this is the two-dimensional plane we're talking about. Let's say P1 over here is, let's say 1, 4, okay? That's a point, okay? And then we got another point over here. Let's say we also got, let's say P2. And then it's 2 and then 2, okay? And then let's say we also got P3, which also happen to be 1 and 4, okay? Just different objects, okay? You know how to create the objects yourself. So now, I want you to think about if I try to evaluate the pink postcondition, what's going to happen when I say P1 dot is equal P3, number one. And number two, what's going to happen if I say P1 dot is equal P2? Before you look at the code, okay, before you look at the code, temporarily, imagine the code doesn't exist, okay, temporarily. I'm going to undo it, okay. If I say P1 dot is equal P3, what would you expect to happen at the runtime? What would you expect to happen normally? Return true, very good. What about the next one? It should be return false, right? Okay, very good. Now, with this expectation in mind, is the current post condition going to give you that expectation? How not? Why not? Okay, you talk about equal sign. I can tell you why I'm using equal sign here. It's also not an issue. Over here, the equals over here, the equals over here is comparing the values for integers. So they're fine. That's not an issue. Okay, anyone else? Okay, are you talking about 1 or 2? How about I say 1 and 2? Which expectation is going to be failing at the runtime?
So if equals always return true because it's doing an assignment.
You say is equals always going to return true because it's doing an assignment. It's not doing an assignment. Remember, forget about Java. This equal sign here means equality. It doesn't mean it's assignments. But we only talk about a post condition over here, right? Yeah. Okay, how about we go one by one? Anyone want to speak up before I say anything? You want to say something? Stretching your back. All right. Why not? All right. So, okay, yes. Nothing to do with type. It compiles. Type checks okay. Yes, like current over here basically simply ensures at the runtime, since we know the current objects like P1 is of type points, so it makes sure this is simply just point. That's going to be dealt with already for you, so that's not an issue.
Is that something to do with shallow copy?
Nothing to do with copies. It's only about logic over here. Okay, before I get to you, yes. Let's not worry about adding variables. I'm talking about as is. What's the issue? Yes, go ahead. No, other than is equal, no. Other than x, other than y, they're simply just points. So you can use equal sign to compare integer values. What do you mean you don't have to compare them if they're the same objects? What do you mean? Anyone else? Okay, how about I give you a little bit, yeah, you want to say something before I give you guys a little bit more hints. Actually, this one is really important, okay? Okay, anyway, that's okay. That's why we have the review, right?
Yeah, it's dumb, but should we just say current equal to other or something?
So you say current.x equals other. No, nothing like that. No. Okay, guys, how about this? Without telling you the answer, let's focus on number 1 over here. For number 1 over here, okay, let's try to have a look. Number 1 over here, we know that the current object is P1. Agree? That's a current. That's a context object. So this will be current. On the other hand, P3 would be other, right? That's a particular call. In this case, when we say x, which is current.x equals other.x is true. Agree? The same points, right? They're both 1. And then current.y equals other.y will also be true. They're both 4. So that means true and true will give you true. Seems to be okay. Seems to be fine. Now, apply the same logic to number 2. What's going to happen? Are you sure? We talk about P1 and P2, right? So now P1 is current. And P2 is other. Right? Let's be careful. So now current.x is 1. Right? 1 over here. Current.y would be 4. Now other, which is P2, other.x would be 2. And other.y would be also 2, right? 2 and 2 over here. So now when we evaluate this postcondition again, we have current.x equals other.x, false, agree? What? Well, 1 equals 2 is false, right? If you have no idea why, I cannot help you. Okay, good. Okay, and current.y equals other.y is also false. False and false will give you false. So that means it's going to be a postcondition violation, right? Okay, so now that means it's going to be a postcondition violation. So what's wrong with this second scenario over here? I'm recording, yes. Yeah, I'm recording, yes. Okay, what's so wrong with the second scenario over here? Yeah, we expected this to return false, but it actually gives us a postcondition violation. In the first one, we expect it to be true. It doesn't give us a postcondition violation. There's something wrong here. Yeah, something to do with that. But let's go back to the very source of problem. The purpose for postcondition over here really is to specify the obligation of the supplier. And in this case, isEqual is actually a query that returns a Boolean, right? But P1 over here constrains nothing about the result. It only constrains what the clients are supplying as input values, which might be P1 and P3, in which case you're lucky they are equal, so the postcondition will succeed. On the other hand, when you try scenario number 2, P1 and P2 over here, the x and y values are not equal, in which case you should return false. That should be expected from the supplier. But you're actually just checking this condition over here is going to be false, so it's going to be a postcondition violation. That's wrong. Any question about this? I hope it's not too tricky, right? Are you all right? Good. Okay. So now, next question. How do we fix this? You're suggesting, okay, what you're suggesting is something like this. Okay, let me write it here. I would say, is this really the fix? Yes, say that again. Not equal, you mean the tilde or equal sign? Tilde. Current not equal. Other? Not equal, okay, reference comparison maybe. Other? And then? Or that thing over there. Isn't that still following the same wrong path? Because over here, you also didn't mention anything about result. Basically, yeah, just before I take your answer here, basically the postcondition here, for every query, you must somehow constrain what the value for the result should be. That's the problem, okay? Yes, go ahead. Actually, do block is actually not an issue over here, since we're only considering contracts, right? We're not considering implementation. Yes? The whole thing implies true. Interesting. When you say the whole thing over here, okay, that is not a fix over here. Let me undo it. When you say that whole thing, you mean over here, right? Okay, the pink one implies true. Again, result doesn't appear there, does it? Well, right, you see, the very problem about this postcondition here is the truth of this postcondition here does not depend on the value of the result that's returned by the supplier. It only depends on the value that's passed by the clients. That's the problem. So that's why in scenario number 2, where you actually expect to return false, but you will actually fail the postcondition. In scenario number 2, the correct behavior should be, if they are not equal, result value should be false, rather than failing the postcondition. Okay, one more try and then I'll give you the answer. Okay, we shouldn't talk about this for 2 hours, right? In that case, I'm pretty sure everybody will fail. Okay, yes?
Why don't you just make P1 equal to result?
P1 equals to result. Okay, well, that's not the right syntax, but I see what you mean. Okay, that's, let me undo this fix. So now the correct fix should be something like this. Okay, I'll write it out incomplete. So, and then we'll go over that, the two scenarios. The correct result should be, first of all, the result over here, you must mention that somehow. So that's the return value for the supplier, right? The way we constrain that is to say result being either true or false is going to correspond to the truthfulness of this expression over here. Okay, result is equals x equals x and y equals y. Okay, let me put a parenthesis to make sure. You see the difference here? See the problematic one I put down originally and see the new one I'm putting here. The only thing I added was I'm trying to compare that Boolean result with the result. So now let's try again, okay? Especially scenario number 2. If I try scenario number 2 over here, P1 dot is equal to P2, okay? And now let's look at the right-hand side first. So we know current dot x will be 1 over here, current dot y will be 4 over here. So that means 1 here, and then 4 here. And then other dot x will be 2, which is P2, right? And then other dot y will be also 2 over here. So that will be 2 and 2. So now we know that 1 equals 2 will be 1 equals 2, true or false? False, good. False. And then 4 equals 2, false, right? Sorry. Should make fun of you. Shouldn't. I shouldn't. Sorry about that. Nobody would know, actually. Yeah. Okay, false and false will be false, right? So that means the right-hand side is actually false. What used to be the problem was in the problematic postcondition is going to fail. But now, since we are comparing this false value over here with the result. So now, if the implementation result from the supply is correct, result should be false. And false equals false will be true. If the implementation was wrong, it's going to be true. True equals false will be false. Then we're going to have the postcondition violation properly. Okay? Is it clear? It's actually quite important. Okay? Yeah. Actually, I'm glad I got a chance to talk about this. Yeah. Okay, guys, any other questions about this before I move on? Yes?
This is the same as result implies that and that implies result.
You want to say two things, right? You want to say result implies that, and that implies result. Okay, so the question was, basically, okay, let me just add a new page over here. Basically, what you're trying to say is, let me just say this. When I say ensure over here, and then, let me just say in general. Actually, I'll just put it down. When I say result equals some expression over here, right? That's what I put down. What you're asking was, would it be equivalent as follows? Let's say I split it up into two postconditions. I would say result over here implies this. And then I also have this implies result. So instead of just one postcondition, I got two postconditions. Are they equivalent? Any idea? Logic. Should be, right? Okay, 1090. So P equivalent to Q is the same as P implies Q and Q implies P, right? Yes, both ways. All right. I leave one exercise for you. One. So I'm glad you mentioned this one. Let me make it clear. Exercise. Think about it. Let's say I still got this ensure over here for the points, okay, ensure. And then I have that particular postcondition called P. Let's say rather than having equal sign, which means if and only if, equivalence, if I only got result implies, okay? Okay, I will talk about the answer with you anyway, okay, but I want you to think about it. Implies, okay, current.x equals other.x and current.y equals other.y. Okay, you can see the only difference is, rather than saying equal sign here, I just say implies, logical implies. Is it okay or not? Well, intuitively shouldn't be, right? Because implies and equivalence, they're different logical operators. Okay, you're right. This is not appropriate. However, how can it go wrong? That's a problem. How can it go wrong? Okay, false implies true is true. I like that. That's definitely the right direction. Can you go a little bit further?
This is true on this fault.
No, not there yet. Yeah. So okay, that's a very good very good thinking process here. So now the hints would be, let me put it down. We know that for implies, false implies true is just going to be true. Okay, good. Can anybody go a little bit further? Given this. Yeah, I agree. False implies false also will give you true. But I would like to have false implies true. I would like to have that. That one's actually the key hints. Okay? Let me give one more hint. Now think about the false. You can see that false over here can correspond to the result over here, right? Okay? Think about false is basically produced by the supplier. Sorry, by supplier. Somehow it's saying the following. If the result value produced by the supplier is simply just false, and then somehow it doesn't quite matter what the right-hand side expression value should evaluate into, right? The postcondition will just be satisfied anyway. That's what it means. I'll repeat, okay? Basically, overall, this postcondition over here is going to be satisfied if the whole implication will be true. We know that one particular way to make implication true is by having false implies true, okay? And now, specifically, the false over here can simply just be produced by the supplier, right? So what does that mean?
If the is equal logic is wrong.
Yeah, if the is, yeah, I agree. If the implementation logic for is equal is wrong, can you give me more specific example? How can it go wrong?
How can the logic
How can the logic for implementation go wrong?
say the supplier is checking y is equal to x and
Not quite, not quite. It's actually even simpler than that. Okay, let me give you, okay, anybody want to suggest anything? Basically, my question is, can you suggest to me given that this is the new, given that this is a new postcondition, me as a supplier, my job will be extremely easy to satisfy this obligation. Can you suggest one line implementation for me to satisfy this postcondition, even though it's completely wrong? Huh? Return false or result is assigned to false, right? Good. Can everybody see the point? Okay, I'll just write that. What I will do is I'll say do here for the is equal. If I say simply result is assigned to false, one line implementation, that means I always return false. Apparently that's wrong, right? Especially for scenario number 1, we expect to return true, but it returns false. But the postcondition will say okay, because false being the return value, implies anything, it doesn't matter what the expected value is, either true or false. Overall, it will just be true anyway. So the postcondition will just be passed. That's wrong. Okay. Guys, any question here? We're only playing with some very easy rules of the logic, right? Back in 1090. That's why I said in the beginning of the course, this course is going to be practical use of the logic. Okay. If you kind of more or less follow the idea, that's good. Maybe just rewatch the video to follow completely.
That would be correct because result is false and the second is wrong, comparing 1 and 4 to 2 and 4, that would return false. So
Nope. In this wrong version of the postcondition over here, you can see we know that the return value is always going to be false. Agree? Right? So now the problem is, for implication, if the antecedent is already false, it doesn't matter what the consequence is. And the consequence over here doesn't really matter anymore. The overall result for the postcondition will just be true. So that means you're having some very useless obligation for the supplier in this case. Right? that means this is not working, right? I'm trying to explain to you why it is not working, okay? Okay, so far we have, I would say this type of question either appear on the midterm or maybe in the final. Okay, so you can see it's not really about the IFO syntax anymore, as long as you know what M means and what implies mean. It's really testing your idea about the contracts. First of all, if you miss the mention of result in your postcondition, it's not going to be good. Second thing, if you put something like implies, whereas you should have put equivalence, like an equal sign, that's also not good enough. Okay, okay, good. Question? You know what?
In that case, the implied wouldn't hurt, right? Like I know
Well,
that
okay, basically your question is, well, actually, again, you go back to the very, very original question about why do we need the decide by contract. If you somehow claim that I'm a very good and careful programmer, whatever I write, I can always make sure it's correct without having the contracts, right? But I would say for small scale system, you might be right. You can write some very, even for merge or quick sort, you can write something without having contract. You might be right. But I would say for large scale system where you got so many client supplier, so many inheritance relationship, contracts will definitely help. Yeah.
So does that mean we should never use implies?
No, the lesson from here doesn't really mean that you don't use imply. Implies is there for you to use, only use that when appropriate. Okay. How do you use implies in this case, since you mentioned? This would be a right way of using implies for the same example. You can think about implies can be useful for doing some case analysis to say if this is the case, then this must be the case, right? Otherwise, if something else is the case, I'll show you. Let's say for the same example, what I can say is like this. I will do exactly like this, okay? Basically, I would say result implies, what I would say is case 1, okay, case 1. Okay, and then result implies x equals other.x and y equals other.y. And then I'll have case number 2. So case number 1, I'm talking about if result happens to be true, then the consequence is the two x and y are the same, okay? And then I'm saying the following for the second case. Not result, which means result is not the case, implies it is not the case that x equals other.x and y equals other.y. I'm going to put down the example for you again, so we'll go through it to see why this new version here is going to work. So basically, rather than having a single implies, which is incomplete, that's why it's wrong. But if we have two implies talking about both cases for result being either true or false, then that'll be correct. Okay, let's see why. Okay, think about it, and then I'll put the example down. Okay. And let's say we do have the wrong implementation over here. Let's say result is simply assigned to false. And apparently this is wrong. Okay, somehow one of the postconditions must fail to catch that, right? Okay, let's try the following. Let's say P1 and P2 and P3. Okay, let's say for P1 it's actually I'll just give new numbers 2, 3. P2 is 2, 3. And P3 is 2, 4. Okay, let's try that. Now let's try two scenarios to see both cases you can catch the error. Okay. So now if we have something like this, let's say P1 dot is equal P2. And the second one is P1 dot is equal P3. Okay, we got two cases to consider. We know that we expect, from number one, what do we expect? True, right? We expect to be true. Number two, we expect it to be false. Okay, that's what we expect. Let's see what is going to happen if we try to run through this wrong implementation. Okay, for case number one, let me use maybe green. Okay, for case number one over here. Okay, let's see. So now for case number one, we know that result is just going to be false, right? We're going to assign false anyway. So false over here and also not false. Okay? And then what's going to be the expression over here? What's going to be the value? True, right? Okay, put P1 and P2. Hopefully you see that, P1 and P2, right? It's true. False implies true, give you true. Okay, the next one. Not false will give you true. And then this is, oh, just this part without the not is true, right? Not true, false. True implies false, false. You fail case two. Can you see a trick? Okay, good. Let's apply the same logic for the second scenario. For the second scenario, let's say we use pink over here. Okay, so now let's say we do expect to see false. And in this case, I tell you what, in this case, we might be able to get by because we're just lucky in this case. But let's see, we may or may not be lucky. Let's follow the logic here. So now, case number one, let's see, the result is again going to be false. So look at the pink color, false. And then what would be this expression over here? Should be false, right? Because P1 and P3, the x and y are not the same, right? So this will be simply false. So what we have is false implies false will give us true. So case one is fine, okay? So now what about for case number two? In this case, what about just this part here? So that means we're comparing P1 and P3, right? Over here. So false. Oh, actually, here is P1 and P2, right? Actually, I said something wrong. Let me do it again for case one. Let me do it again. For case number one, let's do it again. Case one over here, result is simply just false. And then we know that for here, it's actually true, right? So false implies true is true. That's fine. And now when we go to case two, false implies true is true, right? Okay. Huh? Case true is also true. You agree? But let's make sure that's the case, right? So now I just worry that I'm doing something wrong. I just want to make sure. So now for case number two, this part over here is going to be between P1 and P3. We know that it's going to be false. Okay? And then not false is going to give us true. And then not false will also give us true. And true implies true will also be true. So now for case number two, if we can get by simply because this implementation simply assigns everything to false, in this case it's just correct. But for another case, it's going to fail. Okay? What I'm trying to do here is I'm showing you implies can also be useful if you want to do case analysis. Right? Okay, any questions? Yeah, so we already talked about a few examples about how you play with the implementation or play with the postcondition. Yeah, do try to get some lessons from there. It could be useful for your projects and also later on, right? Okay, so now your questions. I just started with that as a warm-up, right? So now your questions. Yes?
About that part,
Yeah.
case one, where you have the x equals 5, should it be false?
For the pink part, sure. So for the pink one, we are doing basically P1 and P3, right? Okay. For this result over here, it's simply false, right? Good. So now for this part here, since we talk about P1 and P3, so P1 and P3 over here, oh, it's false, right? So sorry. You're talking about pink one is over here, case two. I circled the wrong thing. Sorry about that. Circled the wrong thing. Case 2 is over here. Okay, case 2 is here. And then what we get is over here, this part, we know it is false. Agree? It is false, and we also got a negation at the front. Not false will give us true. Yeah, that's how we figured it out. Yeah, good. Questions? The case 1. For 2 here, for case 1, what you will get is false. You're right. And then when you say false implies false will still be true. Yeah, maybe. Good. Yeah, questions? The midterm? Yeah, sure. Yeah, so we do have one question request for going over some midterm question. Would you want to go for that? We got other questions before that. Okay, if no question at the moment, why don't we go over the midterm? You might trigger some question. Yes, which one?
So this particular question here, it says this code wouldn't compile. So I have an idea for the answer. I just want
Okay, so now, basically the question, can you see the question number here? 4, okay. Okay, question number 4, hilariously, was just covered yesterday. But I can go over again if you want. That's not a problem. But let's have a look at that, okay? Okay, number 4, right? Okay. Can you tell me the page number? That might be easier. 7. Okay. Good. Okay, this one here. Hopefully that seems familiar to everybody, right? Okay. So now, basically, you know what? I might be able to even get a picture for that from my file. Give me one moment. Good. Oh, actually, that's a generic one. Okay, I will just go over that with you. Just bear with me. What I would do is I'll try to find out where it is. If I can find out, this might be the one, okay? And then, all right, there we go. That's exactly the same. Okay, now let me just reorganize the diagram a little bit and then we'll go over the discussion. I'll try to maybe go right to the points or just go over the point with you. Okay, now this is basically a, oh yeah, I forgot. Okay, there we go. Okay, now over here. So that's the book of any. So we have a book class over here. And then what you have is we have 2 parallel arrays. One array of names. Sorry, one is an array of string. The other one is an array of any. Right? You can see the static type for each element in the array, as we said in the lecture, should be any. What that means is, at the runtime, you can pass any object that is a descendant class of any. What can that be? Basically any class, right? Any of the classes, okay? And then also we have, for the add feature over here, the record is of type any. And also for the get, the return type is any. So what does that mean? That means you can store anything into the book, anything. Because any class, it's any of the classes in IFO is a descendant class of any, okay? And then also, but the problem is a catch. When you want to get something out of the book, you can only expect it to be an any objects rather than like a book, like a string or the dates, right? Good. Having this in mind, let's go over line by line. Okay. I can tell you that first of all, this line is okay. We're just declaring birthday to be a type dates and also phone number to be of type string. Both of them should be descendant classes of any. Okay. And now the second line, we have a book objects over here, which is called B. And then also we have a Boolean variable is Wednesday. We'll see how to use it in just a moment. And then line number 3, we simply create a new instance of book. And now number 4, we simply got phone number as a string object initialized. Okay. Now when we do line number 5, let me highlight it like that. Should line number 5 compile? Okay, so now we talked about type checking rules yesterday, right? Let's review that very quickly. In order to decide why line number 5 should compile, first of all, the static type for B is birthday. Oh, sorry, I circled the wrong thing. The static type for B is dates. Let me say it again. The static type for B is book over here. Okay, and then does book have a feature called add? It does. So this part is fine. And then the formal argument type for the first one, the formal type is string. 虽然 does match the string type. And the second one is of type any. Does phone number match any? It does, because phone number, which is of type string, is just a descendant class of any. Okay, that's how you decide. Okay, 5 is fine. Now in line number 6, we create a new date objects, which is also a descendant class of any, right? And then for line number 7, let's follow the same logic over here, and we simply say something like this. Should it compile? It should, for the same reason. Okay, I will skip that reason, the same. Okay, so now let's look at this line over here. Is Wednesday, which is a Boolean, I'm going to say that is going to assign to whatever expression it is to the right-hand side. The right-hand side is, I know that I actually put for UNA a date objects, so I'm going to get it out to say b.get UNA according to this method over here, or feature. And then whatever I get as a date object from the book, I'm going to call get day of week. Let's assume this is such a feature in the date class. Get day of week is going to return 1 if it's Sunday, 2 if there's a Monday, and etc. If there's a Wednesday, it should be equal to 4. Okay? Should line number 8 compile? I heard no. Why? Why do you need casting?
Because get day of week does not belong to class any.
Okay, very good. So what you should really look at is the static type. Again, compiler is very simple. The way that the compiler decides if something should compile or not is by looking at the static type. In this case, we know that the static type for B over here is book. And get is actually a feature in the book class. In this case, the get feature is going to return an any. That's how the compiler see. Okay? So now over here, that means, let me circle this part here. So that means b.get UNA over here is going to be of static type any, as we can look up right here. Follow so far? And now we are basically trying to say, does get day of week a feature of the class any? No, it's too specific, right? It only exists in the descendant class of any, which is date. So this part here is not going to compile. Okay? But we know the dynamic type for UNA over here is really the date object. We know that. We can only say dynamic type is dates, but the static type is still any. That's a problem. If you're so sure the dynamic type is really the one you're expecting, you can do a cast. Okay? So what you can do instead is something like this. Okay, I'll just put it here. So line number 8 doesn't compile at the moment. What we can do is we can do a cast. I'll put it here. What you want to do you want to do upward casting or downward casting? Right? Because you're already in the any type, you cannot do any upward anymore, right? Any is already the root. So you want to do some downward casting. I'll write it out. So you would say check attached, like an instance of attached, and then we want to cast to the date class. And then over here, I'm going to put the expression over here, b.get UNA over here. So b.get UNA over here. And then I can say S, A, maybe D for dates, okay? And then I'll say then. And now inside the body of the check assertion, I can say is Wednesday is assigned to D dot get date of the week is equal to 4. Okay, so that's a cast over here. as a cast notation here, downward casting. Questions about this? Before we move on to generic, we'll move on to there in just a moment.
This is more of a theoretical, hypothetical question that why doesn't IFO syntax just support curly braces date in front of b.get, so it knows that, just explicitly casting it?
Oh, you're asking, okay. So as you know, as I try to explain in the class, this notation basically corresponds to the following Java syntax, right? Over here. So this is IFO, right? That's just one way to write it in IFO. Well, that's how you write it in IFO. In Java, it basically corresponds to the following. You would say, I'm trying to cast to dates, so I would say dates should be the new static type and cast into D, for example. I would say D is assigned to, and I'm casting to dates. And then b.gets, over here, after that, you can say d dot day of week, etc. Okay? So the question was, why does IFO design this way? It's a language choice. Yeah, just their design choice. For you as a programmer, let's say, if somehow you're forced to use Java, of course you got to learn the Java syntax. If you're forced to learn IFO, you got to learn the IFO syntax. But the idea is really the same. You just have to know either you want to do an upward casting or downward casting, right? Yeah, just a syntax. Yeah. You mean, where? You mean for the IFO syntax? What do you want to do? In line number 8. Oh, I see what you mean. I see what you mean. Basically, you want to do inline casting, right? No, you cannot do that. No, you cannot. Unfortunately, this is the only way, I'll say the only way you can do that, no off. Yeah. Just live with that. Yeah. But again, casting is something that's not just unique to IFO. Just the syntax, I agree. I personally agree. The syntax is not so convenient as in Java. I agree. Okay. Okay, so now, given that we know that this is pretty bad, the having to do the cast. Okay. Sorry that it's a little bit cut off in this screen, but it's actually quite okay on this left screen here. So now, how do we fix it? Okay, so I'll just go on to the next part of the question. Okay, the way to fix it is I'm gonna add a new page over here, and then I can find it. Give me one moment. What I will do is, I think it's right here. Okay, so this is a solution. I will go over that with you in just a moment. I'll find the other one. Image, photo, camera roll. Okay. Now, before I tell you how the solution should be interpreted, apparently, let me just put a notes over here. So this slide here talking about general book, just a book of any, okay, which is bad. Because we had to do cast like this, okay, lots of cast. If you look at lecture notes, actually I mentioned that if you have to put in, let's say 100 different kinds of objects, every time you retrieve a particular one, you have to do an exhaustive check to see which one it belongs to. So it's a very inconvenient for this design. What we want to move, here's the intuition. I would like to draw your attention to the occurrence of any. Let's look at it again. You can see we mention any over here, we mention any over here, we mention any over here. Basically, what we are expecting to see is if you somehow can decide or to commit what kind of element you want to store in the book for this particular client. Maybe the client want to have a book of string, a book of points, or a book of stack, whatever, or book of dates. What you have to do is, if somehow you can link this any here, this any here, and this any here, all the three together, and you can somehow put their declaration to the level of the class, that'll be very convenient. That means any client who wants to use your book class, they are forced to actually declare what the type is for every element in the book. So here's what happens. If you look at the solution over here, you can see that at the class level, we just have this. As you can see, square brackets, and then we put G. And here it doesn't have to be G, as long as it's any name that doesn't clash with the class name, that'll be okay. And in Java, it seems to use angle brackets. Okay, just different syntax. Okay, so now once you have G over here, so now wherever you want to refer to that particular element type, you can say G here, and G here. So now the advantage is this G is expected to be instantiated by the clients. Okay, I will say to be instantiated by clients. By the clients. Okay, let's see how it can be used. For example, let me give you two examples. One is over here. So now we used to say in the bad design, what we used to say was B is of type book. Over here, the client does not specify what the element type is. However, in the good design, we say B is of type book, and we say every element should be a date. So what does that mean? That means the G over here is going to be instantiated with date. And the G, every occurrence of G is just going to be dates. Going to be dates. And going to be dates. Okay? So far so good? So now, let's have a look at several lines. Remember in the bad design, we say that for line number 5, the reason that it would compile was because phone number, being a string, is a descendant class of any. So now, is this line over here the same line? Is it still going to compile in the new design? I heard no? Yes? No? Yes. Really? Are you sure? Let's see. So now when I say b dot add, so now this value here is a string. No problem. Okay? And then phone number here is also a string. However, at this moment, what are we expecting for these arguments? Why are we expecting dates? It's because the client already commit to it at this point. So that's the difference. So now we are really expecting the dates. And string is simply not a descending class of date. So it does not compile. Yes? Say that again. I don't quite get your points.
So the only way to get around it, declaring the book as a certain type is only by being able to cast that value to whatever.
Exactly, yeah. So if you don't use generic design, that means you just have a book of any or book of something. So yes, in general, you just need lots of casting. Yeah. Okay. So now let's look at another line. Okay. After this, can we have a look at this line here? Is this line still going to compile? Really? Yeah, birthday, right? Okay, yeah, okay. Birthday is of type date. Right? As we declare over here, it's of type dates. Is date a descendant class of date? Yes, so that's still okay. But now, what used to not to compile in the general design where we need cast? What about in the new design over here? Is it going to compile? I heard yes. Okay, let's figure out. The problem for before was when we say b.get over here, when we look at a static type for get, it's just any. But now when we look at b.get over here, since the client already committed that to be a dates, so now the return type is going to be dates, right? So that means static type here is going to be dates. And day.get, day of week, will be whatever it is, right? So that's okay. So now, let me just make a conclusion. You should really know the difference between the two versions over here. In the case of the general book, you're being very accommodating for adding things into there. So whatever you try to add, it will just compile. But when you get something from that, you have to do explicit cast. That's why in general it's very bad. Okay? On the other hand, in the case of the generic book, you require the client to commit to the type over here. Right at declaration time. That means whenever you're trying to get anything into the book, the compiler will not be able to check to see whatever type of object you're trying to put into will be a descendant class of the type that's just committed by the clients. Not only that, when you are trying to get something out from the book, it's also going to have the static type that's consistent with what you put over here. Okay? So you can see the many advantages for the generic design. Yes?
The only way to do it is make a new object and change the type
What do you mean to get around with that? Because this is already the good design. What do you mean to get around?
Line 5.
Line 5.
Did not compile it.
Oh, I see. So you're talking about line number, you mean this line here? Or? Yeah, this one here, it simply wouldn't compile. So what would you like to do?
So just make a new object B1 and then
Yeah.
declare it as book string.
Exactly. Okay, let me just go there. Okay, so now let me just emphasize a little bit just exactly what you said. So now what I can do is I can say B2, okay? B2 is of type, let's say book of string, let's say. Now what I would like to ask you is if I say B2 dot add, let's say some string value over here, and then over here I'll put the phone number, the same string objects. I'll say phone number. Versus when I say b2.add, also some string name over here, and then I will just put the same dates. Okay, just this birthday over here. Okay, I'll say birthday. For the case of B, where every element is of type dates, we know that this is not going to compile, but this is going to compile, right? So now what about for the case of B2? Shouldn't that be the other way around? Because now every element in B2 is actually of type string, right? That means we're going to replace every occurrence of this G over here by string. And now including for this G over here is going to be string rather than dates. And here is going to be string. So now that means when we try to add, the second argument over here, the formal type should be just string. Now, is string a descendant class of string? Yes. So that would be compilable. On the other hand, for the second one, birthday is a type dates. Is date a descendant class of string? No. So that wouldn't compile. So now, what does that mean? That means if you want to decide whether a generic collection compiles, look at what's the element type that's being instantiated by the clients. Okay.
Straight would be a better implementation in this case, because we'd be able to cast a string into a date, whereas we wouldn't go back.
Yeah, well, I see what you mean. But for this particular example, I just want to show you that you can add some two things that are completely different, like a string. Yeah. Yeah.
There was a question saying if you implement it this way, it would be the problem.
Yeah, I would say in general, if you want to choose a generic type, choose the, for example, I'll give you one example. Let's say this. Yeah, let me just answer your question in a more general sense. Okay. You're basically talking about the choice for the type. And we add a page below. Actually, you do have a page below. Okay. So now let's go back to, let's say we got this generic book over here. Let's say we do have it. I'll present two possible design of decorations, and you can tell me which one you think is better. Let's say book one, book, where remember the student, resident students, non-resident student example, right? So let's say here I put students. Case number one. Book number two, I'd say book, I put resident students. Now, can you really say which one's bad, which is good? You say B1 is better? Why?
It's more general, whereas if I have a collection of students in general, it could be one, but if I just want to look specifically only resident students and nothing else, then I would know.
Exactly. So now, I would say in general, B1 and B2, you wouldn't say which one's better, which one's worse. It's really about what you need. Why would you choose B1? If you choose B1, what does that mean? So if you choose B1, let's say the consequence would be, let's just do a very quick review. If you choose B1, that means when you want to store something into the book, you can store students, resident students, and non-resident students, right? That's one for the storage. If you want to retrieve something back and call some feature on that, we know that every element in the book is now of static type students, right? So what about retrieve? The only thing you can expect would be whatever you can expect on the students, which would be, for example, tuition. Is premium rate part of it? No. premium rate is only specific to the descending class, right? So premium rate, no. If you want to talk about discount rate, no. So that's why in the slides I had yesterday, I'll show you very quickly. If you go to the slides for yesterday, let me show you that particular slide. It's about the design. If you go to generics, basically the last one. Okay, if you look at that over here, right? Let's say over here, yeah, go ahead.
What if I try to putting resident student into the foreign students, I downcast, say that's resident student, instead of just putting it in, would I not put it in the values for resident student if I call it?
You're saying that you will downcast. Okay, I should really write a code. Yeah, say that again. Let me mention this, and then I will just go through your example. So go to the inheritance lecture. Go to the inheritance lecture. I want you to go to basically design principle, polymorphism. Okay, I want you to look at this. Okay, this is part of the design choice you should really want to make. Okay, let's just go to that very quickly. I'm saying the following. Let me just make it bigger. Good. Let's say if I declare S of type students, so that means you're only expecting to call feature that's already defined on the students class only, right? If you find yourself having to do such cast very often, for example, whatever I get from the S, I want to cast that into, do a downcasting into resident students so that I can call maybe set premium rates. If you find that you have to do this so often, that means the original design decision for S being of type student is wrong. You should have declared it as resident students, so you don't need any downcasting. Okay, that's kind of the idea. So now back to your original question. Yeah, say that again. Oh, that's exactly, okay, very good, okay. Yeah, let me just complete the rest of the picture. Okay, so that's about B1 over here. What about B2? When I look at B2, when I say storage, I'm being much more restrictive, right? I can only store something that is of type descending class of resident students. In this case, only resident student can be stored into it. So that means if I try to get something out, I can expect that to be resident students only, right? Since I'm being more restrictive on the storage, I can ask for more for the retrieval. So that means I can call tuition, no problem. I can also call premium rates, but I cannot call discount rate. Okay? Okay, everything's related. Question? Yeah, then you. Yeah, you first.
Yeah, it's more of a bigger question. So for question 3, can you go back into definitions of deferred and effective classes and also information hiding? I have an idea how it's not.
Sure. You're basically talking about, okay, let's see. Let me go back to the midterm question. Page number? What's page number? 5, sure. Okay. Information hiding. Okay. Let's have a look at this one here. Okay, actually this one we went over there in the class, right? Just review very quickly. If you look at the 3 classes over here. So we have basically on the supplier side, we have basically cart, and also we have order, right? And the orders, you can see the feature over here is actually, there's no exported to none. So that means just public. So that means any clients for cart can simply get access to the linked list directly, right? And the way you access the linked list is by cursor, stuff like that, okay? And then over here, shop is more like the clients for the cart, okay? And then you will simply say checkout. You're going to say, you can see orders, which is linked list dot start. So start is not available for array, for example. It's only available for linked list. So we say orders dot start until orders dot after, and that just aggregates the cross products, right, between the price and the quantity. And then orders are forth, okay? We say that this violates the information hiding principle, okay? So it's really important to review what information hiding is, okay? Okay, information hiding. We'll get to information hiding for many of the design patterns after the midterm, actually, so it's worth knowing that. Go ahead.
Are we assuming the fact that shop shouldn't have any access to the information inside order?
It's not exactly like that. Let me try to explain. Okay, information hiding basically is as follows. Information hiding basically tells the following. So we have two sides. We have supplier and we have clients. You can think about, for the supplier, there are two parts of the supplier. You can think about one part is completely being public. And the other part is like a private or secret. Okay, so now we're going to use green for the public part. So public is like a green over here, and the secret part is more like, pink over here. Okay, public versus private. So now any clients for this particular supplier can only get access to the public, right? Agree? That's a general mechanism. For the clients, basically, you can only actually get to here with some feature, right? Okay, the client can only do that. Okay, client may have a class over here. Okay, so now we also say that public is the API for the supplier. So now information hiding is saying the following. You should put anything that is subject to constant changes into the private part. I'll write it down. Information hiding is saying the following. Design decision that are subject to constant changes should be hidden from the clients. So now here's the keywords. It's about design decision. Design decision. One very typical example about design decision is what data structure you want to use for your implementation. For example, if you go back to that example over there, you can see here, for the case of the cart, the supplier, they chose orders to be a linked list, which is a data structure. Now in this case, linked list is actually more like a data structure that the supplier is preferring at the moment. What if they change that to array? What if they change that to binary search tree for efficiency reason? In that case, since at the moment, orders is actually put inside over here at the moment. That means as soon as you change the type for orders, let's say from linked list into array, who is going to be affected? The clients. That's not good. You don't want your client code to suddenly not to compile just because you change the orders from linked list into array. Another way to see the information hiding principle is as follows. You want the green part to be as stable as possible. The green part over here, it should be as stable as possible. As stable as possible. And any changes that you made in the private part, it should be not part of the concern for the clients. So let's say if you somehow put the orders over here for information hiding, if you do it over here, that means if you change the orders from linked list into array, that is not going to affect the clients because the client couldn't really access this part anyway to begin with, right? So that's about the idea for information hiding. For your maybe projects, basically, one of the questions I would like you to address in the report would be, tell me how you satisfy the information hiding principle. Right? That's more like an open-ended question you want to convince me or the TA. Right? It's actually very good, something very good, important for you to justify whenever you got design. So this is not just specific to iPhone. No, any language you're doing. Basically, you really want to find out whatever hiding mechanism it is for the language you're programming. It can be, for example, you can declare something to be private in Java, or in iPhone you'll say export something to none. Or for C#, I'm not sure how you do it, but anyway, you'll find it out. My point is, this information hiding principle applies to any programming language you're using for your work. The idea is any design decision you're making now, you want to predict, you want to anticipate if it might change very quickly in the future or constantly in the future. If it's going to change, move it to the private part. So the client doesn't have to depend on that. Yes?
So this would have been correct, assuming that the client requested that it's always a linked list that you're working on.
Okay, I see. So that's a good question. So the question was, let's see the example over here. Let's say, let me just summarize what you're saying. If the linked list choice is based on some mutual agreements between the supplier and the client, saying that we always use linked lists no matter what, yes, in that case, you don't have to hide it. However, I would say most likely it's not the case, because the choice of data structure for the supplier is not part of functionality. It's just how we implement that. So that shouldn't be the concern of the client in general. Yeah. Yeah, him first, and then you.
So the whole issue here is methods like dot item would start failing once we change.
Yeah, exactly. Yeah. So you can imagine that. Yeah. Let me just exactly summarize what you said over here before you go on. So let's say here, because the orders over here is public, so that means if you try to change this into array, immediately the client code over here in the shop is not going to compile, because start, after, and forth, they're simply the cursor operation that's not defined in the array class. So the client code wouldn't compile. So what you should have done would be to hide that particular decision for orders being linked list, right?
So wouldn't this issue be always solved by implementing it as an iterator pattern?
That's exactly what the iterator pattern is for. Exactly, right?
Yeah, so your question about in our projects, we should hide them. So implementing it as
Yeah, so iterator pattern is definitely one way to solve about the data structure problem, but sometimes you may want to hide other decision. So remember I said design decision. I'll try to give you more concrete example as we move on to the semester. So let me just say this. When I say design decision over here, so design decisions, right? It's plural. That means one example would be the choice of data structure. Okay, I'll try to give you more example, but it's more than that.
Yeah, I was asking
Yeah.
about the other ways.
I'll try to give you more example maybe after the midterm. Yeah, as we go. If I just mention it now, it will be too complicated. Okay. But design decision is a very general term. It can be even about how you want to decouple your functionality in different classes. The way you decouple the classes, it can be also information hiding. But we'll get there. Yeah. No, not really. So when you declare, well, for you as a supplier, you have to make the adjustment to see which part should be private, which part should be public. It's completely your freedom. As long as, okay, so here, if you look at the picture here, for you as a supplier, it is really important to make sure whatever API you decide to have, the green part, is sufficiently powerful or expressive for your clients. All the functionality they would like to have, you support it in the API already. And of course, besides the API, there might be many other implementation attributes or many helper features that you might have. For those that the client shouldn't worry about, you put it in the secret part, right? So striking a balance between the green and the pink is something that you should really try to justify, okay, when you do your design. All right, questions? Anyone? Question number 4. Oh, let's see what question. Question number 4. Oh, by the way, I remember you mentioned something about defer and effective, right? Good, good, good. Okay, let me just say that quickly. So now, you can have direct correspondence like this. When you say deferred, and also you have effective, IFO over here, and then we have Java. I think, okay, so now for IFO, when you say defer, it simply means abstract, something that is not implemented. So when you say a class is deferred, that means the class is just abstract. you cannot use the class as a dynamic type for your runtime. Okay? What about effective? That means it's not deferred, which means it's something that has been implemented. Okay? And Java simply means non-abstract or concrete.
But isn't it by default?
Well, when you say by default, maybe this is what you meant. Let's say in the case of iPhone, if you say class, let's say points. Yes, you're right. In this case, it is the case of effective. If you want to make it deferred, you have to explicitly say that. Like in Java, right? If you want to make the class abstract, you gotta say abstract, right? And by the way, for the bound notation, in case you haven't picked up yet, deferred means star or plus. Star, right? Okay. And effective is plus. Okay, don't forget. Plus simply means it's implemented. Anything that's implemented. It can be a feature or it can be a class. If a class is effective, that means every feature is implemented. I would say you should really study thoroughly the bound diagrams for bound diagrams such as the iterator pattern and the singleton pattern. That's important. If you understand all the construct over the expanded type, defer class, defer feature, effective class, effective feature, it should be all right. Yeah. Any others? We have time, right? It's completely up to your questions. Yeah. We haven't? Oh, I thought we have. Okay. I keep got distracted, right? That's why. Okay, number 4. Oh, yeah. Number 4, what is number 4? Oh, sure. Oh, you want to just go over exactly? Okay, sure. No, why not? Actually, I think number 4 for A is basically about which line doesn't compile, right? We talk about it. I think A, we already talked about it. And for B, invalid syntax, basically it's using the check, which I also did, right? You mean the iPad, right? Sure. B.getDavid, yes. Correct. Exactly. Did you miss the lecture yesterday? Oh, that's okay. Yeah. Anyway, yeah. That's exactly what we said yesterday, but that's okay. Many people might miss that too. Okay, let's have a look. Basically, what I want to see is this. Okay. Yeah. Let me. You can also check the slides. It's also on the slide for generics, but let me mention that anyway. Okay. Let's go back to our friend for generic design over here. Okay, over here. Let's say we do have a book of G. Okay. You know, let me add a new picture. Add image, photos, camera row. This guy here. Okay, that's our generic class over here. So now, let me ask you the following, right? It's a warm-up, okay? If I say B1 is of type book of students. Okay? And then let's apply our knowledge. Tell me if this line will compile or not, okay? If I say, and then I got something over here, okay, it doesn't matter. I'll say B1 dot get, let's say Stella, okay, some students, and then dot set, oh, sorry, let me say it again, dot tuition, something like that. Would it compile? Yes? No? Yes? Why would it compile? Yeah, okay. In case you have forgotten about the hierarchy, so this will be students, and then we have 2 inheritance. We got resident students, non-resident students, right? And then remember we got name. I'll try to recall from memory. Name, we got courses, And also we got tuition. Have I missed anything? Okay, anyway. And then for resident student, we got premium rates. So now over here, you can see every one of, for tuition is effective. That means it's implemented. And also got premium rates. We got set premium rates. And now we got tuition over here. And remember I said plus plus. What does plus plus mean? It's implemented twice. What does, actually intuitively that's implemented twice. That means it's redefined, right? It means redefined, okay? It's redefined, yeah, okay? Well, you can think about implemented twice, right? That means implemented once in the superclass and implemented another time. Good, and NRS will be discount rate, and then set discount rate, and also tuition plus plus. Good, given this, now again, should this line compile or not? Yes, right? Because now the fact that we say students over here, G is going to be students. That also means the static type over here for get will also be students. Now student class will be the static type for this expression over here, this feature call, the return type. And student does have tuition defined. Good? Now, have another one. What about I say B1 dot get Rachel, let's say, dot set premium rates. Would it compile? No, right? The same analysis here, because B1 get, all we know is it's only going to be a students. And student class does not have the premium rates, only exists in the descending class. So this would not compile. What if we are so sure it is pointing to a if we are so sure it's really pointing to a resident students class, then do a cast. Okay. Okay, good. Hey, any more questions? Yes.
If the client wants to make a book of different types, then would that be with implement any? So generic rather than just having.
Sorry, can you say it again? I don't quite catch your question.
If the client wants to implement like different types of books into one single book.
Oh, okay, basically, okay. The question was, it's a good question. The question was, what if a client wants different types of objects to be stored into the same book using generics? What should they do? Okay, that's the question, right?
Well, I was wondering if for simplification, any is better.
Okay, I can address your question. Yes, let me try to draw some picture to show you. Okay, this is best understood in using a picture. Okay. Let's say this. Let me put it this way. Let me make it very general for you, okay? Say a client wants to store objects of types. Let's say C1, which is one type, C2, another type, up to Cn, just n different types, okay? Just make it very general. How should they declare? Using the generic book. I'll now use the example to show you. So i.e., if I say B over here, and then I'm trying to use the generic book, and what should they put over here? That's the question, right? Okay, in general, if you got C1 and C2 up to Cn, different types, what should you put over here in the question mark? Here's the conceptual idea. You have to figure out if there's a common ancestor for these classes and choose the lowest ancestor. For example, if C1 somehow is here, C2 is here up to Cn, if they already have some common ancestor class, just choose that class over there. Okay? If somehow C1, C2, and Cn are so unrelated, it's guaranteed to be a common ancestor, which is any. That would be the worst case. I'll give you some not so worst case, okay? For example, if you got C1 being resident students and C2 being non-resident students, in this case, the common ancestor would be students. Another example, remember the smartphone example, okay? Let's say if I want to get, for example, let's say iPhone 6s, iPhone 6s Plus, in which case the lowest ancestor would be just, let's say, iOS, thank you. In this case, you would choose iOS. You wouldn't choose, for example, like a smartphone. That would be a little bit too high, right? Choose the lowest ancestor. Okay, so the idea is choose the lowest ancestor, common ancestor of C1, C2, up to Cn. So that's the idea. So hopefully that answers your question. Yeah, again, it's a very good question. It's a very good design principle. I would say typically at the time you want to have a book object, you should have a fairly clear idea about what you want to store. If you're really not sure, just put any. It's a very bad design to begin with. Maybe later on you find that you always want to just store students, just put students, right? Yeah. Actually, that could be a nice design principle, like a small one to apply to, maybe for your projects. Could be, right? I'm still undecided for your project. I'm still thinking which one should I go. I have several ideas. Yeah. Oh no, they're the same project for all the two sections, for both sections. Yeah. Yes, questions? You mean the architecture? Oh, you mean how to figure out the, oh, okay, sure. That's possible. You know what, the best way to do it would be, first of all, let me find out where that node is. Give me one moment. I think that's before we talk about inheritance. Okay, that's the one. Okay, sure, give me one moment. What I would do is I'll make a copy of that. And then I'm going to add it over here. Okay, there's no way you can see clearly what's going on here. So I may have to wipe out certain parts. Okay, let's see how we can do this. Matrix, what's the best way to do this? Okay, give me one moment. Yeah, actually, you know what? Let me try. Give me just 1 minute. Okay, just you guys can take some quick break, but I will just take 1 minute. Okay, I hope that's reasonable enough. Okay, good. Not as clear as how we begin with, but I'll just briefly mention that you can also rewatch that particular lecture. Okay. Okay, the question is as follows about the iterator pattern. Basically, this might be also relevant to your lab test. You might be expected to do something like this. Okay, so I'll just mention that. Okay, let me just put a local over here, and then let me tell you what the story is. Okay, so we got, for the iterator pattern, we got a class called database. Okay, database we want to inherit from iterable. And iterable itself has a single generic parameter, right, just G. But here I just put it in a color to see, we'll filter this in a little bit later. Okay, but for database, we do have V1, V2, and K, which means when we instantiate for value 1, value 2, and K, we have to follow this particular order. Okay, good. And then, since we inherit from iterable, we must define this defer feature, which is defer in the iterable level. So new cursor is of type iteration cursor. Also, it takes on generic parameter type over here. So far, so good? Okay, we got iterable, we got new cursor. And then, okay, so these are just the reference classes for you to look at, iterable and also iteration cursor. And we might also have to declare another myCursor class over here, and then also will take some generic parameter and also inherits generic iteration cursor, like that. Okay. Now, the most important part is for you to infer what these orange boxes should be, right? That's a key thing. Okay. The short answer is you should look at how the clients is expecting to use these classes in their tests. As I said before, the test-driven developments, tests are simply just documentation of what's really expected. So let's have a look. So now, what I would do is, let me just erase this part, which is the most crucial part. And I will do it again. Let's say over here, let's say the client simply declare a D variable of type database. Let's say we simply say database value 1 is simply a matrix. And value 2 can be, let's say, a card. And the key can be a string. Okay, let's say we start with this. So this is completely decided by the clients. For you as a supplier, you have to work accordingly. Okay, so what does that mean? That means matrix over here is going to instantiate V1 for database, right? It's going to be matrix over here. And card over here is going to be V2, right? V2 is going to be instantiated by card. And also string over here is going to instantiate K, right? So K is going to be string. Okay, follow so far? Good. So now, the next thing we should look at is over here, the records. So what should the records be over here? So the records is simply just going to be a linked list of certain type. Okay, let me just leave this empty just for now. Okay, the records. It's going to be a linked list of something for the element type. And then the way the client is expecting to use your database is going to say across D. Notice one thing, across notation is only for iterable objects because D of type database was already declared as iterable. That's why we can use the across notation. Okay, so we say across D as some cursor, right? And then, remember, when we say cursor over here, it's as if we say cursor is assigned to D.newCursor, right? Implicitly, by the across loop, implicitly. So the across actually does something for you under the hood. One thing is, whenever you declare this cursor variable, it's as if you say cursor is assigned to whatever iterable object it is, .newCursor. Okay? Good. And then over here we say records over here, which is going to be a linked list of something, .extend. And then we say cursor.item. Right? Good. So far, so good. So now, what we can do is we can try to infer the types. Okay? There's one more thing for the client to decide. One more thing. Okay? What I can do is, if I put in orange over here, okay, orange over here, if I simply say the following, linked list of record, okay, and then I will say record being the cards and the matrix. Okay? Now we have enough information to figure out the rest for the supplier side. Now, I want you to look at this particular part over here. When we say records is going to be a linked list of record, right? And the record itself is going to store card and matrix, only the two values. And it's actually in the order of value 2 and then followed by value 1, right? Any order that the client like, any order, okay? So this is slightly different from how I presented in the lecture, so you can see both versions. Both are valid. So now what we should do is, given that we know about this for the type, let's have a look at this one over here, this line. Okay? So this one here, what does that mean? That means over here, cursor is basically returned by the new cursor. Agree? The cursor over here. I say implicitly, whenever you say across iterable as some cursor variable, under the hood, the new cursor feature is going to be called, and then as a return value for this particular variable cursor. Okay? So now when you say cursor.item, right? And remember, cursor must be a subclass of iteration cursor, right? Cursor.item, in this case, what should be its type, according to what we said over here? Should be exactly record, right? Over here. So I'll just put it here. So it should be record, and then card, and then matrix. Like that. Okay? So far so good. So that means the cursor the item is corresponding to this item over here. It's corresponding to this. Okay? So now, what should we put back to the supplier? What should we put back? Should we, I can propose one solution here. I can do, for example, if I simply say I'm going to replace G over here simply by, you can see this G over here is a G at a class level, right? And then this G over here is going to be instantiated by this orange part over here, because it's simply iteration cursor, and then whatever type is going to instantiate G, right? So now I'm going to give you one possible solution, and we'll see if that's good or bad. If I simply copy verbatim what I have over here, if I simply say iteration cursor, and then I will say record, and then card, and then I got matrix. Let's say that's what I have, right? Do you see any problem with that, conceptually? So what we are doing over there in the red, we are saying that for database V1, V2, and K, okay? V1, V2, and K. Of course, one possible instantiation for V1 and V2 and K would be matrix, card, and string, okay? But now, in the new cursor feature over there, we're declaring to say it doesn't matter what V1, V2, and K are. We simply return each item as a record of card and matrix. Basically, that's what we're trying to say, right? Let me write it down. This solution over here is basically saying this record will be this of this type for any V1, V2, and K. So I'll give you one extreme case, okay? If I say over here, if I say D, let me just erase this, it's not relevant anymore. If I say D2 is of type database, and what I will put is, I'll put Sudoku, for example. Does it sound familiar to you? Right? Hopefully, right? If you don't know what I'm talking about, you're in trouble. Okay. Sudoku, and then I will put maybe a matrix. I will put something just different. And then integer. Let's say this. Let's say me as a client, I declare D2 of this completely different types. Sudoku account integer versus matrix, card, and string, just different clients, okay? However, according to my original design over here, even for D2 with these two value types, I'm still going to return back to them record of card and matrix. That's why this original design was bad. You're just being too specific to client number 1. But for client number 2, as soon as they change the instantiation for V1, V2, and K, you're still stuck with this particular specific instantiation. That's why this is bad. How can we make it more general? To make it more general is easy. This is how you do it. Remember what we said before. When we actually said matrix over here, matrix correspond to V1, and card correspond to V2, and the string correspond to K. That's the way you can make it more general. Okay? So now, if you look at the record of card and matrix, okay, let's figure out the order over here. So the card over here correspond to V2, right? I'll put V2 here. And the matrix over here correspond to V1, V2 and V1. So rather than putting card and matrix, I can just put V2 and V1. That's how I make it more general. Okay, make sense? Good. So now, once I'm done with this, so simply record with V1 and V2. And I can replace every occurrence of the orange part with record with V2 and V1 for this case. And also for my cursor over here, the same. Just replace them. Okay? Okay, that's a very quick overview of what we said. Yeah.
Although, yeah, I was kind of lost in that explanation, but that's not the point. I'm trying to understand. I think I
That's the point. If you lost, that's the point, right?
So basically what we were trying to get at was, although you have a database of 3 generic types, you can make another record of 2 generic types and replace each generic in the database as that record, and that's fine.
Right. Okay. How about this? Let me recap exactly what we have done from a bird's eye view, and then you can ask again. Okay. So now the big picture is we want to support the iterator pattern, right? We want to say our application class, which is called database, is going to inherit from iterable. But now the problem is, how do we figure out what the generic type for the iterable is? And also what the generic type for a new cursor is? Somehow these two must be the same, right? Good. The answer to this question is we should figure that out by looking at how the client is expecting to use the database. So look at some test that will be given to you. In this case, let's look at the database user. When you look at database user, for this particular client, they're using just D, declaring matrix, card, and string. We might have another client declaring D2 of just different types for V1, V2, and K. So we want to make both clients happy. That's why the class must be as generic as possible, okay? So now for client 1, we already got sufficient information to figure out the order of the generic parameter. This is how. If you can see the records over here, the records is going to be extended by every element that's returned by the new cursor, which is like from cursor to item over here, right? Cursor to item. So now how do we figure out cursor to item type? We look at another part of the client code, which is it's going to be a linked list of record of card and matrix. And over here, the card over here correspond to V2. And the matrix correspond to V1. That's how we can go back over here and say it's going to be a record of V1 and V2. Sorry, V2 and V1. Right? That's kind of the big picture. Exactly. Yeah. 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 A common mistake would be you simply just repeat exactly, specifically what the client 1 is declaring, like a card and matrix to here. And that's not going to work for client 2. That's why you want to make it general. Okay, guys, we got another 10 minutes. Any questions?
One simple question.
Yeah.
So when we have so if we have let's say a double for loop,
Yeah.
then we make it into like a Venn diagram kind of rather explicit, whatever it's called, a mathematical statement. When we have this dot, what does this dot mean?
Oh, okay. It's about math. So if you are asked to draw some Venn diagram or to write some contracts in mathematical notation, so there are 2 ways you can write it, okay? Let's say this. Let's talk about, remember in lab number 2, one of the class invariants for database is the keys must be unique, right? Let's use that example, okay? Let's say we want to have invariance over there. Okay, invariance let's say the keys being unique. Okay? Actually, we talk about something similar in the class, like you have an array of integers. You want to make sure the integers are unique, right? Similar. Okay, now we write it out. So there are several ways you can write it. Either you can say, let's say nested. Okay, you can say for every, so this more or less corresponds to your across notation. Okay, you can say for every I, and then just colon, and then you would say 1 less than or equal to I, less than or equal to maybe keys dot count. Okay, now over here, basically this is more like a for I such that, okay, such that, and now you have a choice. Either you can just put another column here, or you can just put a bullet points. Either way, bullet point, as you see in the midterm question there, is basically like it is the case. Yeah, basically what you learned in 1090. Let me just finish this. Yeah. Yeah. Yeah, so this is like a range constraint for your variable, right? Let me just make it complete. And then it is the case, we can introduce another variable, let's say for every j, such that 1 less than or equal to j, less than or equal to keys.count. And it is the case, right? And then we can say the following. So there are two ways for you to write the predicate part. You can either say I is not equal to j, implies keys at position I is the same as, oh, it's not the same as, let me just write math, not equal to, right? Math notation. Keys at position j. Okay, that's one way to write it. Now, you learn something called contrapositive. Does that ring the bell? In 1090. What's contrapositive? Anyone? Yes. That's brilliant. Very good. That's contrapositive. Okay? So now, that means this part over here can be rewritten without sacrificing any semantics by saying keys I the same as keys j implies I is equal to j. Okay? The same. So now, let me say one more thing. Okay? So now you can see over here is nested. It's more or less corresponding to what you will write as a cross loop. But in math, we can simplify that a little bit. Okay? Basically, I can try to collapse the nested quantify into a single one. What I can say is this, in green. I can say a single for every, I would say I and j. And then I can put a range constraint a little bit more complicated. I can say 1 less than or equal to I, less than or equal to keys dot count conjunction 1 less than or equal to j, less than or equal to keys dot count. And then it is the case, right? And now I can put exactly the blue part, right? I'll just write one version. I not equal to j implies keys at I not equal to keys at j. So both versions work. Okay? Of course, the green version is not directly implementable in IFO. You have to somehow translate that into nested across. But if you only ask you to draw a bound diagram or to write contract in mathematical form, that's okay. Okay. How they convert that into IFO code, right? Okay, sure. Since I already talked about it. How would you do, for example, let's say, if you're given the green part, how about that? How would you convert that into IFO code? Okay. The answer is look at how many dummy variables you have. That will correspond to how many nested levels you should have. Since you got I and j, right? That's basically like for your lab number 1 about matrix. Since for every matrix you want to go over every cell, you gotta go. You need 2 dummy variables, one for row, the other one for column. Okay. So now in IFO, already in red, you would say something like. Let me write in the next page. Okay, you would say across, let's say 1 dot interval, right? Keys that count, yes. As I would say I over here. Now, be careful. I over here, as the programming level, is a cursor to integer. On the other hand, I over here is an integer, right? We're talking about different domains, math versus programming, right? So now let's go back to programming. And then we can say or. Okay, and then we can do another cross, of course, or and and. And we have another cross. Yes, 1 until keys.count. SJ, thank you. And then we'll say or. Now, how do we do the rest? Huh? Copy and paste. No, well, that would be convenient, wouldn't it? But yeah, let's not be like, yeah, that's okay. I'll just write it. It's quick. Yeah, basically we're gonna say, oh, actually not just copy and paste. Let's say I. How do you say not equal to in IFO? /, right? Okay. Don't really do backwards slash. That'll be escape sequence, right? /. Okay, I is not equal to j implies. And then you would say keys and position I, like that, right? Oh, good. I like that. I like that. Good. Good. Yes. You know what? I'll write it down first and I'll correct it. Yeah, good. I don't care. I don't take the midterm. You take the midterm. Right? Good. Basically, okay, very good. I.item, J.item, and over here, I.item. So if you write something like in the red, this will be how the TA will mark your paper, so be careful, okay? All right, that's about it. Okay, guys, we have more time if you want. But I would say, yeah, anything, yeah. Oh, okay, good question. The question is, if you want to cross rather than the integer interval, which I will recommend you do it if it's possible, basically what you're saying is, if you simply say something like that, rather than saying this, you basically say, let's say across the keys. The problem is, if you only say across the keys as some cursor, so every time you talk, so you don't really have the power to actually say if the indices for the keys are different, then the corresponding elements are different, because now you lose the index, unless you have something like this. I tell you what, it might be possible. Let me sketch the idea for you. Let's assume, we know, oh, actually it's possible, because we know that the keys are unique, right? Okay? What I would do is like this. You can say something like this, across keys as, let's say, K1, all, and then I can say across keys as K2, and then also we got or, and. Actually, I never used this. I think is there a way to figure out where the index is? Like an index, cursor index, right? Okay, good. How about we try that? What you can say is, you can say K1 dot cursor index okay, not equal to K2 dot cursor index implies K1 not equal to K2. So that's possible. I tell you what, in even more general, let's say if you forgot, you actually got cursor index, you can actually implement it by yourself, right? You can simply just do something like, this will also be acceptable. You can say, I can say get index of key, for example, right? And then K1. You can easily write a feature to help you with the contracts, so given that the keys are unique, right?
The keys are equals.
Yeah. Anyway. Okay, any more questions? Go ahead. I would say either to take this one, using across the keys, or the last one, doesn't matter. for this case, both work. All right, no more questions? Okay, we're in time. Okay, sounds good. I'll post the recording, so good luck. I'll see you next week. All right.